All right, so we're going to continue with the equations today. So last time we learned how to solve first degree or linear equations in detail, different scenarios with or without fractions. So today we're going to see how to actually apply what we learned to solve actual problems. Okay, so problems in real life are not always written in mathematical equations. They usually come in word form of a word problem or some scenario that we have to figure out and turn it into some mathematical equation in order to solve it. So that's what we're going to learn today. We're going to learn what we call the problem solving strategy. Okay, so we call that problem solving. Okay, so basically strategy is basically the steps of solving a problem, or the procedure of solving a problem. So for word problem, we have a few steps that we need to follow in order to solve a specific problem. First, let's write a problem, okay? So word let's say twice a number twice a number increased by six is, let's say, 12. Okay, find that number. Okay, so this is a little word problem here. Sometimes word problems can be easy to see or understand and solve right away, maybe mentally. Other times, if the problem is longer and has more words and variables and numbers, it might not be as easy to do it in your head quickly. So that's why we have what we call the problem solving strategy. So when you have a problem like this, what you want to do first is always read your problem as many times as possible, as you can or as needed, to understand it first. If you don't understand the problem, it's going to be very hard to solve. So make sure you understand what you're doing before you solve it. So understanding a problem is basically 50% of solving it. Okay, once you understand something, you're halfway there into solving the problem. So let's read again. It says twice a number increased by 6 is 12. Find the number. So we need to find that number here. So like I said, number one, I'm going to read and understand the problem. Depending on how long or how complex the problem is, you may need to read it more than once. Okay, so read it as many times as possible and understand it. So here it's clear. So twice a number that we don't know, increased, we know the meaning of increase, right? What is the operation for increase? Everybody?
Multiplication.
No, increase. When you increase something, what does that mean? What is the operation?
Addition.
Addition, that's right. So this stands for addition. So twice a number, when we say twice a number, it means that number twice times 2. Twice a number, if it's 3 times 3 and so on. Increased by 6, of course, is 12. So twice a number increased by 6 is 12. What do you think is translates to in terms of mathematical symbol?
It's equal.
Está ya. Sí, que nadie me agarre, por favor. Gracias.
Equal.
Exactly, that's for equal. So, and then of course this is 12. Find that number. So we're referring to the same number. So basically the second step is trying to understand every symbol, translate everything. So that number, let's call this number that we're looking for x. So twice x increased by 6 is 12. Find that number. So we're referring to the same number here. Okay, that number, referring to the same one, x. Basically, we're looking for, we have one unknown here and one number. So that's steps 2. Basically, what we did was label the missing number. Number or sometimes numbers. So we did label that number here. Of course, again, make sure you understand every other word. Please keep your mic muted, Jessica. Please keep your mic muted. So read the problem we did, label the missing number of numbers. Now that we did that, number 3, we need to turn this sentence into an equation. So we're going to translate translate into an equation. Okay, so let's write this in a sentence. So twice a number x, that means 2x, increased, that's a plus, by 6. So increased is plus, the opposite is decrease. So decrease means minus. Equal 12. That's the most important part in solving the problem, to get the right equation. If you don't get the right equation, you are most likely not going to get the right solution. So it's very, very important that you translate your problem correctly. Otherwise, it will be something completely different. Okay, so now that we have an equation, what do you think we do in the next step, step 4?
Find 2x.
That's right, find x or solve. So we need to solve the equation that we just wrote. This one here. Okay, so again, we'll learn how to solve first degree equations in the past couple of classes. So this is an application of what we learned. Okay, so let's solve that. So what's the first step in solving this first degree equation? What do you do first? So we want to isolate the x. Okay, we want to find the value of x. We want to isolate it. So what is the first step in solving this equation? Two x plus 6 equals 12. You want to solve this for x. What do you do first?
12 minus 6.
12 minus 6. That's right. I mean, you need to cancel this 6 or simply move it to the other side. So we're going to subtract this 6 to cancel it. The opposite of positive 6 is negative 6. Do the same thing on both sides. So these cancel out. So you end up with 2x. 12 take away 6. That's 6. Finally, divide by 2, divide by 2. So the number we're looking for is 3. Okay, so that's the solution to this equation. So twice a number increased by 6 is 12. Now, we have one more step, last step left. How do we know that we got the right solution? So what do you do in the 5th step? We need to make sure this is a solution. So that step will be to check this and see if it works. I'm going to take this number, we're going to try to plug it into this problem and see if it works. Not into the equation, but the equation, something that you wrote, you might not be correct. But the equation might not be correct because you did it yourself. You could have made a mistake and you found you did the wrong equation. So it's not reliable to plug it here. It's better to plug in the very first or the original version of the problem, which is the word problem. So when you say twice a number, that number is, we just found it to be
3.
3. I do 2 times 3, that's twice a number, twice 3. Increased by 6 is 12, or equals 12. We're not sure yet, so that's why we need that question mark over the equal sign. So we say, is it equal to? So then we simplify both sides and see if we can get an equality at the end or not. So if we get 2 equal sides, it means the solution works. It's the right solution. Otherwise, you might want to go back and check everything. Start with checking here. So we're going to backtrack. Start checking your math here first before going back and checking solving the problem. If it's good, then you go back one more step up, check the translation. So you backtrack, starting from here. You could possibly make a mistake just simplifying this. Even though the solution is right, you might, it's possible to make a mistake here. It doesn't mean you made the wrong equation. So start backtracking. So from here, check the equation. If it's good, check the translation all the way up. So when you simplify this, you use the order of operations. So that's 6 plus 6. And again, we still use that question mark. We're not sure yet till the very final step. 6 plus 6 is in fact 12, which is 12. So that solution checks. We don't need that question mark anymore here, but because we know for a fact that 12 is 12. So that solution, we say, works or checks. If you get something not equal here, something wrong, for example, 6 equals 7 or something, then that means something is wrong. So again, you have to double check and backtrack. But in this case, 12 works. So that's the solution to the equation. Okay, so these are the main steps, or these are this is a procedure of solving word problems of any sort, basically. Always read and understand it, label the missing number of numbers, translate that into a math equation or a system of equations or function or whatever it is. You solve that, whatever you end up with from here, you solve it, and don't forget to check to make sure you got the right answer. So that's one application of linear equations. So we learn things, we learn them for a reason in order to apply them or use them to solve actual real world and word problems. And this is one of them. Okay, let's look at another one. Let's make up another word problem. So let's say 3 times so 3 times the difference of a number and 6. Let's say decreased by 3 or by maybe 9 is, let's say, 15. Okay, again, find the number. Find the number or that number. Okay, so that's our word problem. Again, make sure you understand it, read it, understand every technical word and its translation into mathematical symbols. So we have 3 times the difference of a number and 6 decreased by 9 is 15. Find the number. So this is another problem. Interesting. So again, make sure you go over each word. So 3 times the difference. What do we mean by the difference? What operation is that? What do you say are the difference of 2 numbers? What do you do to find the difference of 2 numbers? What is the operation? So when you mean difference,
Subtraction?
that's right, it means subtraction. So 3 times means 3 multiply number, then decreased by, what is decreased again?
Subtraction.
That's right, increase means plus or add, decrease means subtract, by 9 is 15. Find the number. So there's a little difference here. So first step, read, understand. Okay, understand. Number 2, label. Okay, so how many numbers are we looking for here? Just one number, the difference.
Dice, es que tú no llamas. Digo, pues yo nunca me dijiste eso ayer que ibas a salir.
Just one number, x. Decreased by 9 is 15. Find the number. It's the same number we talked about here. Let's call it x. You can call it a. You can give it any letter you want. It doesn't matter. So we labeled it x. Number 3 from here is to translate. So just translate this sentence into an equation. Here's the deal here. So here we had twice a number means 2 times x, that number being x. But here it says 3 times the difference. So it's not 3 times a number. So it's not going to be 3 times x because it doesn't say 3 times a number. It says 3 times what? 3 times the difference. Okay?
Minus. Yes.
That's right. So we have a multiplication here. So 3 times, this times is 3 times, not a number. If it was 3 times a number, we would write it as 3x. But here it says 3 times the difference. It's 3 times.
Difference is gonna be, yes. So
That's right. What goes inside the parentheses?
x minus 6.
Exactly. So the difference of these two.
Yes.
X minus. So this is a multiplication. You might be confused with the x. That's why we avoid writing it. We know that we learned from algebraic expressions previously that when you have a number next to parentheses, this means a multiplication. So this multiplication here, 3 times is here, times what? Times the difference. So put that difference, or maybe sum here, could be sum, could be a product for multiplication, but it could be quotient. Quotient is for what? Okay, so quotient is for division, products for multiplication, sum is for addition, and difference is for subtraction, whatever the word might be. So 3 times something, what is that thing? Could be here plus, minus, multiplication, division, whatever it is, depending on the problem. Okay, so 3 times the difference of a number and 6, decreased by 9. So see here, there's a comma, another comma, so we're done with the 3 times the difference. So it's 3 times the difference. Comma means there is a new term or a new number. So this would be decreased by 9. Decreased by 9 means minus 9. Okay. And then is 15. Again, is translates to equal and 15. So that's the most important thing here again, is to get the right equation. So 3 times the difference Difference means to subtract two things. If it says quotient, then you would use a division here. Product, multiplication. Sum will be addition, as we explained. 3 times the difference decreased by 9 is 15. So that's our equation. Next, we solve it. So what's the first thing you do to solve this equation here? What is the first thing you do?
Distribution, 3 times x and 3 times minus 6.
Very good. So we're going to distribute this 3 over
Yes.
3x minus 18, 3 times. Bring the negative 9 down, and the 15. And we combine like terms, so 3x negative 18 minus 9, that will be, it's the same sign, keep the same sign, and add the numbers. That would be negative.
27.
That's right, negative 27 equals sign and 15. So now it looks like this equation, we're gonna cancel the negative 27, so we need the opposite of this to cancel it out. So we're gonna do positive 27, positive 27. These cancel out, you end up with 3x. And here we have, what is this equal to? 40, 42, right? So this is 42. What's the final step? Divide by 3, divide by
3.
right? What is x? B, 14. So that's the number we look for, or the number we're looking for here. Again, we want to check it. So final step 5 is to check. So 3 times, I can always check against the problem itself, not the equation. This doesn't mean it's correct. It's something that you wrote yourself or we wrote ourselves, so we can't rely on this to be the correct equation, so we want to check in the original problem here. So 3 times the difference, so 3 times the difference of x and 6. What is x again? X we solved is 14, and 6 decreased by 9. Okay, decreased by 9 is 15. Is, we're not sure yet, 15. And then simplify this using the order of operations. So now we have an arithmetic expression. This was an algebraic expression because it had numbers or letters and numbers. We had to multiply first because we couldn't do anything inside. We didn't have any like terms to combine inside, but this one is an arithmetic expression. Where do you start from? Thinking about the order of operations.
We start from subtraction, 14 minus 6.
That's right, the parentheses. We're not going to distribute. It's better to do the subtraction first because we have like terms. So that's 8. We have 3, take away 9 and 15. What's next?
We're gonna multiply 3 and 8.
That's right, we're going to multiply to 3 and 8. That would be
24 and minus 9, and we get 15.
that's right, 15. Final step, what is 24 take away 9? That's
15.
15, that's right. As you can see, that 15 equals 15. That's good. So that's our number here. It is 15. The number we look for here, x, basically is 15. We checked it, and the problem is done. Please stop drawing on my screen. Whoever is drawing something here, please stop doing that. I know it's probably accidental. Thank you. It's still here. All right, so that's basically how you solve word problems. Depending, I mean, the word problem can differ, from one to the other, depending on the keywords or how long the problem is, but the strategy is the same. It's always going to be these five main steps that you need to follow in order to solve the problem. Jessica, are you there?
Yes.
Okay. Are you drawing on your screen, or are you touching your screen accidentally? See, this green here is from.
Oh yeah, I'm sorry.
Okay, so try to erase that. Let's do another problem, or um, all right. So another type of problem is another example here. So let's do a little bit of a more complex problem here. So, but before that, let's do the sum of consecutive numbers. What do we mean by consecutive? What does the word consecutive mean?
It's like 1, 2, 3, 4.
That's right. The numbers that are in order. Two consecutive numbers mean the number after the other. Consecutive. For example, two consecutive days are Monday, Tuesday. So they are directly one after the other, not like Monday and Friday. Those are not consecutive. So another application of linear equations, when we find a consecutive number or consecutive numbers knowing only their sum, not knowing the numbers themselves. Let's say the sum of two consecutive numbers is, for example, 13. So we know that consecutive number is, for example, when you have, if the one number is x, the next one would be x plus 1. The following one would be x plus 2, and so on. This is what we mean by consecutive numbers. For example, if you have, let's say, 10 here, what is the next consecutive number to 10? It'll be 10 plus 1, which is
11.
11. And the following one would be basically 12.
12.
Because you just take the original number, the first one, we add 1 to it. When you go to the next one, you add 1, the following one, you add 2. And the next consecutive number is when you add 3 to the first number we started with. So 10, plug 10 here, 10 plus 3 is 13, and so on. So 10, 11, 12, 13. Like x, if we don't know the first number. So basically, whatever that number is, add 1 to it, then add 2, add 3. So that's what we mean by consecutive numbers. So let's see how to solve a problem involving that. So the sum of two consecutive numbers, let's say, is, I don't know, 7. Find the numbers. You probably already see the numbers, but let's see how to find it systematically using linear equations, because this is about applications of linear equations. So you probably already see what consecutive numbers add up to 7. What numbers? What numbers are those? What consecutive numbers add up to 7?
3 and 4.
That's right, 3 and 4. So if the numbers are small, it's easy to spot. But if it's a lot bigger, might not be as easy. So let's try to find these numbers by using an equation. So basically, this can be translated into an equation here. The sum of two consecutive numbers is 7. If the first number is x, let's say we don't know what the solution is. If one of the numbers, or the first one of them is x, what's the next one in line? What's the next number in terms of x?
Plus 1.
That's right, it will be x plus 1. Whatever the first number might be, the following one, the consecutive one in line will be whatever this number might be plus 1. So x plus 1. So this is the first number. This is the second number. As you can see, it's one after the other. So the first number, so it says the sum of two numbers. This is the first number. This is the second number. Means equal 7. So that's the equation. If you had the sum of 3 numbers, then you would have x plus 1, x plus 2, just like here. If you have the sum of, let's say, 8 numbers, so it will be x plus 1, x plus 2, x plus 3, and so on until you make 8 numbers. For this time, we have only 2. So this is the first number. The next one is whatever this is added plus 1 is 7. Then you have this simple first degree equation which we can easily solve. So we have x plus 2x plus 1 is 7. Then we're going to subtract 1. So 2x is 6. That means x is 3. So x is the first number. If the first number is 3, what's the next number? It will be, so one of the numbers is x3, the other one is x plus 1. That's right, x plus 1. So x plus 1, x is 3, will be 3 plus 1, which is 4. So those are the consecutive numbers. You have 3 and 4. Okay, so one number, or the sum of two consecutive numbers, let the first one be x. Okay, if the first one is x, then the following one must be x plus 1. The next number in line will be x plus 2. The next one will be x plus 3, and so on. So that's basically how you find consecutive numbers, knowing the sum only, not knowing the numbers. We didn't know them here, but we used the equations to find them. So for 2 numbers, it's not that bad. Let's see now how to find the sum of 3 consecutive numbers. Let's say we don't know 3 numbers. We want to find their sum. For example, let the sum be, for example, 36. Okay, so the sum of 3 consecutive numbers is 36. Find all of them. Find them. So 3 consecutive numbers here. We want to find all of those numbers. So it's not as easy as the previous example when we had only 2 numbers. So it may take you a while to figure out those numbers, but luckily we can do this easily using first degree equations. It doesn't matter how many numbers you're looking for. It doesn't matter what the sum is. We can easily do this by turning this into an equation. So let the first number be x. If the first one of the three consecutive numbers is x, what is the next one again?
X plus 1.
That's right, that's the next one. What would be the third one in line?
The third one?
The third one, yeah. So
X plus 2.
that's right, it would be x plus 2. So whatever that number might be, the next one would be that number plus 1. The third one would be that number plus 2, and so on. So according to the problem, I should say the sum here. So the sum of three consecutive numbers is 36. Find them. So we don't know them. We don't have to guess them. Just label the first one, let it be x. The next one got to be x plus 1. Third one x plus 3. So according to the problem, the sum, which means addition. So the sum of all these three is what? Is 36. So if you take the first one plus the second number plus the third one, according to the problem, this will be 36. That's the most important part, probably the hardest part of solving the problem. The rest is easy. You just basically solve this equation and find x. So what do you think we do here in order to solve this equation? What do you do first? So we're trying to find x. What is the first thing you do here?
Addition of x's.
That's right. We're going to combine all the like terms. So we have x plus x plus x. It will be 3x. Okay, then we have 1 plus 2, that's plus 3, 36. Simply combining like terms and simplifying. Again, refer back to the previous lecture. We discussed this in detail, how to solve first degree equations, and then proceed to isolate the x. Final step is division by 3, division by 3. So the first number in line is, what is it? 33 by 3 is 11.
11.
Okay. What's the next consecutive number after 11? Should be
12.
Let's call this x1, x2 is 12, and x3 is,
13.
that's right, will be 13. And according to the problem, these all should add up to 36. So let's see if they do that. So let's try to add up all these numbers at 11. We have 12. We have 13. As you can see, that's 6 and 3. And that's exactly what we wanted. So three consecutive numbers, we didn't know them. We only knew their sum. But since they're consecutive, that means one of them is bigger than the other by 1. So this increments or increases by 1. We only needed 3. So if you have 5 here, then you're going to continue this 5 times. You're going to do x plus 1, plus 2, plus 3, and plus 4, and so on. The same thing works with the difference. If this says difference, if it says the difference of two numbers is something, though instead of addition, we'll be using subtraction. So that's basically how you solve problems involving consecutive numbers. Does that make sense, everybody? Any questions?
No questions, sir.
All right, so let's try to do another example. This time maybe involving some coins. So there are, let's say, 18 coins. Maybe that's too much. Let's just make this something smaller. For example, 7 coins. Seven coins here, and let's say 7 coins. 7 coins in a jar or whatever, in a pocket, something. in a pocket. If the total amount of these coins is, let's say, let me do a little bit of math here to make sure we have the right numbers. If we have a total of 115 cents, 115 cents, and there are, or there is one, there's one, so let's say there are 7 coins. Let's say, let's say these are quarters and dimes. So the total of the money, all these together, is 115 cents. And there are, or there is one, a dime, one dime more than quarters. Okay, so let's understand the problem again. So there are 7 coins. We have 7 coins in a pocket made up of quarters and dimes. How many cents are in a quarter again? Quarter has 25 cents, and a dime, how many cents are in a dime? Everybody?
10.
A dime has 10, right? 10 cents here, and here, I mean 25, and then we have 10 cents for a dime. So the problem is we have a total of 115, and the total number of coins is 7, but we don't know how many of each do we have. So that's what we're trying to figure out. How many coins, how many dimes, and how many quarters we have that make up this. We have some clues. Okay, so there are 7 coins in a pocket. If the total amount of these coins is 115 cents, and there is 1 dime more than quarters. For example, if there are 8 quarters, the dimes are 1 more than what the quarters are, so the dimes will be 9. Just an example, if there are, for example, I don't know, 11 quarters, there are more dimes by 1. There's one more dime more than quarters. If we have 11 quarters, then the number of dimes would be 1 more, would be 12. That's what this means. So we know there's a total of 7 coins. We know that the total amount of money is 115. Or we can write it in dollars, possibly in dollars. Actually, you don't have to put it in dollars, just use cents for now. So we want to find how many exactly of each coin do we have. We have some cents here. So let's try to translate this into one equation. So this is a bit challenging, but it shouldn't be that hard. We're just going to translate exactly what we have into an equation and solve it. So let's say we have, also if the number of quarters is, if we have x quarters, right? Well, the numbers of quarters is q. This is the number of quarters. How many dimes do we have based on this? It would be whatever this is plus
One more.
one more. That's right. It would be quarter plus one.
Quarter plus one.
That's right. So this is whatever the quarters are, and these are the dimes. Whatever number of quarters we have, the number of dimes is this number plus one. Now, how do you get the total of 115? So the total is 115 cents. So you take the number of quarters, which is Q, we're gonna find Q, and we're gonna find D. If you find Q, we're gonna find D. So you times the number of quarters by what? Again, how many, each quarter has 25 cents. So the number of quarters, whatever it might be, we're gonna times those by 25 cents, plus the number of dimes, which is this, we're gonna times that by?
One.
No, the number of dimes to find how many cents. So for example, if you have 5 dimes, how many cents is that? You times it by 10 to get
By
50,
10.
right? But in this case, we don't know the number yet. We don't know, for example, 5, but we know it in terms of Q. So we're gonna take this and times it by whatever that number might be, times it by 10. So it'll be 10, that's the cents, times the number of dimes. Okay, so to find, if you have change in your pocket and you count it, so you count, for example, quarters, how many quarters, you times that by 25, plus, for example, you have dimes also, so each dime is 10 cents. So you gotta times that by 10. So now we can do Q times 25, which is 25Q, plus 10 times D. D is the number of coin of dimes, which is also expressed in terms of the number of quarters. So this will be Q plus 1. So D, the number of dimes we said, is whatever the number of quarters plus 1. So we can replace D with Q plus 1. That way we have only one variable or one unknown to solve for. Instead of using Q and D in an equation, we can eliminate this one by replacing it with its value. So dimes is whatever the quarters, the number of quarters is plus 1, and this is 115. That is the equation. Once you write the right equation, the rest of it is just solving. It shouldn't be that bad. Okay, so let's go ahead and solve this for Q. So it's 25 Q, then distribute this to be 10Q plus 10 is 115. Of course, combine like terms, 25 plus 10, that's 35Q, or 35 quarters plus 10, it's 115. Then subtract 10, subtract 10. So 35 quarters is 105. What is the final step to find Q?
105 divide 35.
We're going to divide by 35. What's 105 divided by 35?
3.
So again, 3, right?
3. Yes.
Very good. So that's the number of quarters. But we need to find, the question says, okay, find, forgot to write the question here. How many of each coins, of each coin? Okay, so that's what the question should have been. How many of each coin there is? So if we have 3/4, how many dimes will there be? D will be
4.
4. That's right. D is whatever the number of quarters is plus 1. So it'll be 3 plus 1, which is 4, because the problem says there is one more dime than quarters. There's one more dime than quarters, and that's why we have, so 3/4, 4 dimes. Let's see if this adds up. Just check, this should add up to 115. So 3/4, if you times that by 25 times 3, that's equal to 75. Again, we times the dimes by what?
By 4.
The dimes, there are 4 dimes by 10. Each dime has 10 cents. So this will be 40. Does that add up to the sum we talked about earlier? Yes, so this adds up to 115 cents. That's basically another application of linear equations. Sometimes the problems can be a lot complex, a lot challenging, but equations can make them a lot easier. So instead of guessing the numbers here and trying different combinations, it may take you a while and you may never get the answer. If you're lucky, sometimes you could probably get it quickly, but when you follow the procedure or the solving strategy, you systematically can find the solution easily in a timely fashion. So everybody should be able to, once you have the equation, it's easy to solve. You just need to translate it into the right one. So this, one of the little more challenging problems that we can solve using linear equations. Okay, so consecutive numbers, numbers of coins. So the problem could be they're written a little bit differently. Instead of coins, it might be students, it might be fruits, it might be tickets or something, but the concept is the same. The words can be a lot different, but in the homework, you will see something like this, but with different words, but basically the procedure is the same. Consecutive numbers also, and again, if instead of consecutive, if it says the difference, instead of consecutive of sum, you use subtraction. And if it's a direct word problem like this, just translate it correctly. Be careful with where to put the parentheses. Translate each word correctly, and then solve the equation. Don't forget to check at the end, the last step to check. And that's basically a few applications of linear equations. So we learn them for a reason. We learn them first. Once we learn the skill of solving equations, we apply that skill in solving actual word problems. Again, like I said in the beginning, the problems in real life are not always written in X's and Y's in nature or physics or science. It's up to us to understand them, put them into word problems, and then turn the word problem into equations and functions in order to solve them. Okay, does that make sense to everybody?
Yes.
Did you guys learn something today?
Yes, of course.
You feel smarter?
Of course.
Very good. So now you know how to count coins in your pockets like a magician, right?
Yes.
Next time someone has a pocket full of change, tell them I can find the numbers without looking at your coins. So that's the magic of math. All right, so again, to recap, so I'll give you the quiz sometime soon on Blackboard or by next class. The midterm is in a couple of weeks. I'll upload a review sheet to Blackboard, give you a couple of weeks to work on it. And any questions you don't understand from that review sheet, write them down and let me know in our next Zoom meeting. And I believe that's about it for today. If you haven't done so already, please join the discussion board and post any issues, any questions you may have there for today. And with that being said, let's take some attendance and call it a day.